Using variables to describe patterns. In previous lessons, we have created input-output tables and talked about the patterns. Now, sometimes it works nicely where we can come up with a statement with just numbers. However, we run into an issue when we want to get into very large numbers, where maybe we don't want to write a table out to 57, or maybe we only need to know a few key numbers within that. And so this is when we are going to use variables to help us describe patterns. So if I look at the input-output table that I have here, I am going to look at both sides. So my input, you'll notice, is going to go up by 1 each time. That's something that we're going to look for. If it's not going up by 1 each time, then we need to backtrack and do something a little bit different. The next thing we're going to do is we are going to look at our output. So our output is 7, 11, 15, 19, and 23. Now, when I look at this, the pattern rule for the output would be to start at 7 and add 4 each time. So this suggests that the input numbers are multiplied by 4. So whatever we go up by every single time is actually what I'm going to end up multiplying by when I create a pattern rule. So if I look at this, I'm going to multiply by 4. So if I look at this input 2, 2 times 4 is 8. But my answer here is 11, so that doesn't quite work, so we need to do something else. Well, in order to go from 8 to 11, we need to add 3. So the pattern rule that relates the input to the output is multiply by 4, then add 3. We can use a variable and expression to represent this rule. So we are going to let the letter n represent any input number. So we can then rewrite it as the expression 4n plus 3 relates the input to the output. So a couple of important things here. First of all, when I have a number and a letter bounced up against each other like that, that's the same as 4 times n. So we often use x as a variable as well. So if I had an x and a times sign beside each other, I could confuse which is a variable and which is multiplication. So we try and get rid of that x as much as possible. The other thing to think about is we can actually think about this almost in a way you guys have been using variables for a long time. So we use in younger grades either a box as a placeholder, or sometimes we put a line and we ask you to fill in that line. These are the same type of things. So the only difference is we're actually just going to use a letter to hold that place instead. Now, if I look at my table, I can do the same thing as I was above. So 4 multiply by 4, then add 3, multiply by 4, then add 3, multiply by 4, then add 3. So each time you can see my input is going through the same thing to get the same pattern of output numbers. So when I have that n, instead of putting it where the 5 or the 4 is, we put it in that same position, and so 4 times n plus 3. We can use a pattern to solve a problem. So Manoa works at a fishing camp in the Yukon. She earns $25 a day plus $8 for each fishing net she repairs. On Saturday, she repaired 9 nets. How much money did she earn? So there's a couple ways that we can do this. The first way is to make a table of values. So I have the number of fishing nets that she is fixing and the amount that she earns. So if she does not fix any nets, she's going to make $25. That is her daily amount that she makes. But each time she fixes a net, and you'll see that this is going up by 1 each time, the amount of money that she makes is going up by 8. And you can see that I've referenced this on the side here. So plus 8, plus 8, plus 8, that's what's going on each time. So I would have $25 for no nets, $33 for 1 net, $41 for 2 nets. She repaired 9, so I can look at the 9 row and I would know that she made $97. Now I could do this by building a table, and it works okay when we're only going up to 9, but kind of like I said earlier, if we were going all the way up to 57, this would take us a long time to get to this. So the other way that we can do this is to use a variable in an expression. So Manoa owns $25 even when there are no nets to be repaired. So we're going to have a plus 25 as part of our expression. And so you can see it here. And then to figure out how much she earns from mending nets, that is how we're going to multiply by 8. So if she mends 0 nets, we multiply by 8, 1 net, 2 nets, 3 nets. And so just like above, this is that position where our input number is. So we're going to replace it with a variable, n, for nets. Now when we choose variables, we often try and pick a letter that matches something similar to what we're talking about. So if we're talking about dogs, we might use the letter D. Nets, we would use the letter N, but it actually doesn't really matter which one we use when we do this. So the expression that I would use is 8n plus 25 or 8 times n plus 25. If I'm using this, then I can put in however many nets that she has fixed, and I can figure out without doing all of the extra steps of filling in the table. So I'm going to put in a 9, and so 8 times 9 is 72, plus 25 is 97. So she would earn $97 that day. Now, in this case, again, that up to 9 is not a huge table to make, but you could see that if I was fixing 57 nets, it would be a lot easier to go through and do this with an expression. Now, when you have this, the other thing you have to be careful of is make sure that you're following your order of operations. Otherwise, you're going to potentially get a different answer. So make sure that we follow those general rules of multiplying and dividing first, and then adding and subtracting second in order to get to your answer. There are some practice questions here. Give them a try and let me know how it goes.